Hello everyone, let's solve some LeetCode today. So today we have LeetCode 1255, that is maximum score words formed by letters. You see, the classic technique to make a problem hard is to just make the title confusing and crazy. And the same technique is also used in the description. It can also be confusing to read for beginners. So we will directly try to understand this entire question with the help of this example. So in the question we have words array, letters array and the score array. So the basic premise or the basic thing that the question is asking is that we have these words, okay? We can make these words with the help of these given letters. And we have a few letters, okay? We don't have all the letters available in the entire world. We can only use these letters that are present in the letters array to create the words that are present in the words array. And each letter actually contains a value, or you can also call it a score. So this particular score array actually tells you the score of each and every letter. Now this score array actually tells the value of each and every letter in the English alphabet. What it means is that this tells you the value of each and every letter from A to Z in the small case letter. So this 1 represents the value of A, this 0 represents the value of B, this 9 represents the value of C, this represents the value of D, this is for E, F, G, H, I, J, K, L, and so on till Z. So the value of Z is 0 here. So what it means is that you will get the letters from here and you will just search for the value of that letter. For example, A is the letter and the value of A is 0 here. And then C here is the letter. The value of C here is 9, right? So we can search for the value of that particular letter. And since these letters actually have a value associated with them, these words that are actually made up of letters also have a value. For example, if I take the dog letter, I have dog. Then what is the value of dog? Well, it is equal to the value of each individual character or letter. So the value of D plus value of O plus value of G represents the total value of dog word. So currently the value of D is 5, the value of O is 2, and the value of G is 3. So the total value is going to be 10. So the value of dog word is going to be 10, or the score of dog word is going to be 10. In the same way, all of these words actually have a value associated with them based on the letters that they are made up of. And also the letters array actually have duplicates. So if I try to make a word like good, what I will need is I will need one O, then this O, and then I will need G, and I can take one D, right? So these many letters are now used, right? We cannot use these many letters for any other word. So what it means is that if I try to create dog again, okay, after creating good, I will realize that I cannot create dog again because I have already used the G word or the G letter to create the good word, right? So it means once I create the good word, I cannot create the dog word because I don't have enough G instances, right? I have a few extra D's here, but I don't have G or any extra O here. So it means that I cannot create dog. I can create the word dad. So I also have a dad word. So I can take this D, I can take this A, and I can take again this D. So then by now we have used all the D's and we have used one A. It means we only have C and A left. So what this means is that the word that you create first is going to decide what other words you can actually create in that way, right? So if you never create good, then you will be able to create dog. If you create dog, you will not be able to create good. And this is what the question is asking. You are supposed to tell what is the maximum value or maximum score that you can have based on the given letters and the words that you can create from them. For example, here we see that we have a few possibility. We can create a set of dad and dog words. So I will have something like this. I will have dad inside of it and I will have dog word inside of it, right? And the value is going to be 21. But I also have one more possibility that I can create dad and I can create good, right? So that will actually give me a score of 23. So I can create another set. So this will give you a value of 23 and it is the maximum value that I can generate based on the given letters and given words. So that is exactly what we need to do. We have to figure out the maximum score that we can generate based on these words and these given letters. So by now you have already seen that we are actually creating sets. Okay, so we have a set like dog and dad and we are actually trying to get its entire value. The entire value will be just 21 and then we will have another set like dad and good and this set will actually have its own value which is equal to 23. The value is just the value of this word plus the value of this word, that's all, right? And both of these are nothing more than subsets of this entire words array. What we are doing is that in one subset we are taking the dog and then we are skipping the cat, we are taking the dad and we are skipping the good, right? And in another subset we are taking the dad and we are taking the good only, skipping this cat and dog, right? So what this means is that I need to go through all the subsets of this words array and just calculate the value for each subset and return the maximum value. That's all. That's all I need to do this. So this entire hard question has now just become simple subsets question. So while creating the subset, we can simply have this index I and we can just create subset with the help of it. So we will basically have a decision tree. I can decide to take the element at index I. Currently it is at dog. So I can decide to take dog or I can decide to skip it. So I don't have dog here, right? Then this will increment, it will go to cat, right? So I can decide to take cat or I can decide to skip it, right? It does not exist. Here also I can decide to take cat and I can decide to just skip it. In the same way, I can decide to take dad also. So I can take dad here or I can just skip it, right? Here also I can take dad and I can just skip it. Here also I can take dad, I can skip it, right? Here also dad I can take and I can skip it. In the same way, the entire recursion tree can be made. But here's one thing that you need to understand. I cannot really create the cat word. Why? Because I have C, I have A, but I do not have T anywhere in the letters array. And that's why creating this cat word is not possible. So on this state, you will not have any branch where we are actually taking the cat word. So what this means is that on this place, there will be no branch in which we are taking the cat, right? So this entire branch will actually just go away and we will only have this branch where we are not taking the cat. That's all. And a similar case will happen when we will run out of the letters, right? So for example, at some point we actually end up creating good. And after that, I cannot have dog. I cannot have dog. Why? Because there are no more G's available inside of the letters array, right? So it means once I create the good, I cannot have dog, and vice versa. If I ever create dog word and then if I try to create good word in the branching, I cannot do that, right? Because there is no G letter available to create the good word. So what it means is that while creating the subsets, there will be times when you will not be able to create a subset or basically a word, and that will be the end of that branch. That's all. So now there are a few optimizations that you can actually do to make things a little bit faster for you, right? So right now we have been given an array for the frequency of the elements right here, and that array is called the letters array, right? So this letters array actually stores the elements or the set of letters that we have at our disposal to use. But suppose if you have this word good, okay, and you try to see if you can actually create this word, then you will have to go through the entire letters array to find the G letter, the O letter, the O letter, and the D letter, right? You have to go through the entire array, which is going to be order of n. So you can simply use something like a hash map, okay, hash map for reducing this time complexity, or you can use a simple frequency array. Okay, if you don't know what is frequency array, we will see in the code, don't worry about it. But you can definitely use these two things to reduce the time complexity from order of n to order of 1, which is pretty good. And in the same way, some of you might be thinking that, okay, we might actually just store the value of each and every word in some other array in the starting itself. But the reality is that while you are actually going in the recursion tree, while you are actually creating the subset, you will have to check for each word whether you can actually create it or not. And the way you check for each word whether it can be created or not is by going through all the characters in that word, right? So I have dog here, so I will have a pointer like k here. The k will be at d first, and then I will check is D still available in my hash map. If it is available, okay, I will shift to the O. Then I will check is O available, okay. If it is available, then I will shift to the G, and if I find that G is not available in my hash map, then I will not go in this direction. Otherwise, if I have G available, I will simply create the dog word and I will keep on continuing the recursion function. So what it means is that in each iteration, I have to go through the entire word anyways, which means that creating an extra space for storing the values of words does not make sense. I might as well go ahead and calculate the value while I'm checking whether we can create this word or not, right? And yes, there will be some bookkeeping also involved in this question. What it means is that you will have a simple hash map or a frequency array in which you will store the count of each and every character that you have, right? So for example, at some point you started creating good in your recursive function. So what you will do is you will take the G, the double O, and the D, and you will reduce their frequency in the hash map or frequency array by 1, right? You will have to reduce it to indicate that you have used these particular letters. Any other word cannot have access to them, right? So if you reduce them by 1, your hash map will update and you will continue the recursive function from the good, right? But once you come back after calculating everything and you have to go through other branch where you are not taking the good, you will actually have to make sure that you are incrementing the character count of these characters by 1 again, so that these characters, the D, G, double O characters, will be free again for other words to use in other branch, right? So this is the backtracking part of this question, where you are actually increasing the count of each and every character that was present inside of this word again, so that those characters will be available for use in another branch. That is the backtracking part. So now we understand the logic behind solving this question. We will simply have a hash map or a frequency array to keep track of the count of letter that we still have available to create more words, and then we just get all the subsets for this words array and then calculate the maximum value that I can find in all of those, and then just return the maximum value out of them. Simple as that, right? So here we have the code. We have used the comments to indicate what each step is doing right now. So currently, first of all, we are creating a count array. This is going to be the frequency array in which we are going to store the count of each and every character that we still have from the letters array. So that's what we are doing. We are creating a frequency array right now. So this frequency array is going to be the size 26 because we only have 26 characters in the English alphabet from A to Z. So for each character that is present in the letters array, we will take that character and then we will just have the integer value for that character and the integer value of A, and this expression will give us an integer number. What it means is that suppose if the character is A, okay, so the character here is A and the character here is A also, right? So if I subtract these two integer values, I will get a 0. What it means is that at count 0th index, we will have a single A, right? That's what we are doing here. So this will help us to create a frequency array. You can go ahead and use a hash map also. You can just go ahead and code a hash map. That is also a very good option. But here I just use a frequency array because it is usually less used, less common. So I just wanted to use it here. So it is good to see these kind of operations once in a while to make sure you do not forget them. Then we have this backtrack function inside of which we have the main logic. First of all, we have this base condition, that is, if we ever reach the end of the words list, which means we have found a particular subset of the words array, we will simply return 0. Because we have reached an index where we don't have a word, so the value of a non-existing word is simply 0. And that's what we are returning in this base condition. Now, once the base condition is done, here we have a few choices. Okay, first of all, we are making a choice to skip the current word, okay, to create the subset. So we are choosing the skip option first because it is simpler to implement. We have the max score variable here and we are running the backtrack function on the index plus 1 element. Here we are simply skipping the current word to create the subset. Now if we want to include the current word, we have to get access to it. So here we have access to the current word. Then the current word score is a simple variable that I'm setting to 0 here. And here we have a variable which will tell whether we can actually create this word with the help of currently available letters or not. So in the starting, I'm setting it to true. And then here in this particular loop, we are checking whether we can actually form the word with the help of currently available letters or not. So for each character in the current word, we are taking the index of that character. We are figuring out the index by taking the integer value of character, subtracting the integer value of a character out of it. And then we will use the index to get the count of the current character in the count array or the frequency array that we created above. Okay, so here in this line we are simply subtracting the count for that character in the frequency array by 1. Okay, and here we are taking the score for that character from the score array and adding it in the current word score variable. And here we are checking if the count of the current character from the word is negative or less than 0 in the count of the frequency array. We will simply set the can form to false. Here we are not breaking, okay? We are not breaking. We will keep going through the entire word, probably making the count of characters less than 0 or negative, but it is fine because we are going to revert these changes later on in the code. So once the for loop runs, we have the answer whether we can form this word with the help of currently available letters or not. If we can form it, then only we will go in the other branch where we will actually take this particular word in the subset, right? So I'm running the backtrack function recursively on the index plus 1. The difference this time is that the hash map or the frequency array have a different value now. Okay, we have updated the frequency array or hash map. In case when we were skipping the current word, we were not actually updating the hash map or the frequency array. But right now we have updated the hash map or the frequency array based on your code, and then we are actually running the backtrack on the index plus 1, which means the next recursive call will have a different set of available characters to use. And then this call will actually return some value. Okay, we will add that value to the current word score, and then this is going to be the total value that we can generate till now. Okay, and then we will compare it with the maximum score that we generated for skipping this particular word. So whatever choice returns us the greater value or the greater score, we will pick that. If skipping the current word gives us greater value or greater score, we will take that. Otherwise, we will take this particular value and store it in the max as variable. And at the end here, regardless of whether we can form the word or we cannot form the word, we are just making sure that our hash map is now updated again to be in the previous state. So what here we are doing is that we are taking each character from the word here, and then we are just increasing the count of that character in the count array or the frequency array or the hash map. Simple as that. Earlier we were decrementing it. It was minus equals to 1. Now it is plus equals to 1. To make sure whatever we did in this earlier for loop right here, we are actually making sure that these changes are no longer present in the hash map for the other branch. So that's what we are doing here. We are making sure that those changes are reverted. And then at the end, we are returning the maximum score that we found till now. So that was our backtrack function. And here outside the backtrack function, we are actually calling this function to get the answer that we need. So we use the backtrack function and we call it on the index 0. So we are starting from the first index in the words array. And this will give us the answer, the maximum value that we can generate. So yeah, let's run this thing and see what happens. So yeah, our solution runs in 3 milliseconds and beats 99.73% solutions on LeetCode, and it has also passed all the 53 test cases. So it is a pretty efficient solution. Now let's look at the space and time complexity for the solution. So the time complexity is 2 raised to the power n multiplied by L, where L is the length of the largest word that is present in the words array. So suppose that we have words like go, we have get, right? And we have something like LeetCode. So out of these, we have LeetCode as the largest word because it has the maximum number of characters. So the length of this word is basically the L here. This 2 raised to the power n is coming from the fact that we have to run the DFS recursive called 2 raised to the power n times to find all the possible subsets, okay? Because in worst case scenario, we might need to find all the possible subsets for the words array. And while finding the subsets, each time we have to run that loop in which we were checking whether we can actually create the current word based on the available letters we have. And that loop is going to take at max, okay, at max in the worst case, this particular length. So that's why I have L here. And the space complexity is going to be order of n because in the hash map, the maximum we can go for is 26, right? Hash map of frequency array, all of them at max can store 26 characters only because there are only 26 characters in the English alphabet dictionary, right? So this is going to be basically a constant space complexity, right? But this n is coming from the fact that we are going to use recursion, and recursion is going to have a stack, right? A call stack, and that call stack can go at max order of n. So that is why we will have space complexity as order of n. So yeah, like the video, subscribe the channel. If you have some kind of question that you would like me to target, or you have some kind of topic that you would like me to talk about, just let me know in the comments. Now we will meet in the next video. Till then, bye.